Okay, so now we need to use the remainder theorem to identify zeros of a polynomial. Sounds very fancy. It's not going to be such a big deal. Okay, get our pencil. And let's get started with a title here, which is using the remainder theorem, the one that we just learned about in video number 38. Okay, using the remainder theorem, to identify zeros of a polynomial. That's, after all, what we've been doing for a long time already, polynomials. Okay, so I need to put two questions side by side, if I can. The first one is f of x f of x is equal to 2x cubed minus 4x squared. And let me put in parentheses up here that we're going to be using synthetic division. Just like we did last time with the remainder theorem. Okay, minus 4x squared minus 13x minus 9. Okay, there's no gaps again, so you don't have to worry about any 0x. 3, 2, 1. Fine, there's no gaps. And here's our job. Our job is for a 0. Here's our question. Our question is for a 0 of this polynomial. Okay, now I need a space. Problem number 2 next door. And it's a shorter one. If I've got 2x squared, f of x is equal to 2x squared plus 3x minus 14. And the question is 2 a 0 of this polynomial? That's a minus, be careful. That's a minus, right? A minus. Is 2 a 0 of this polynomial? Same question, both sides. So we're going to use the remainder theorem, and that means we're going to use synthetic division. Let me show you what I'm talking about. Okay, we're going to be using synthetic division for both situations. Okay, so over here I write a 2, I write a minus 4, I write a minus 13, I write a minus 9. I put down the L, and on the left-hand side I put down a 4. Okay, over here on this side I put down a 2, then comes a 3, right? It goes from x squared to x to the number, then comes a 3, then comes a negative 14. I put down the L, and then I put the 2 on the upper left, right? The 2 upper left, and this one is 4. We're testing 4. It's on the upper left. Okay, let's start with this over here on the left side. Bring down the 2. 4 times 2 is 8. Negative 4 and 8 is 4. 2 times 4 is 8. Negative 13 and 8 is negative 5. 4 times negative 5 is negative 20. And what do we get at the end of the day? What do we get at the end of the day? We get, at the end of the day, we get something big what we get is a negative 29, correct? It's going to be a negative 29. Okay. Just want to make sure that I did that correctly. Did I do that right? 4 times 4 is not 8, it's 16. I blew it. 4 times 4 is 16. I blew it. And negative 13 and 16 is equal to a 3. We were in class, you would have caught me. Bring down the 2. 4 times 2 is 8. Negative 4 and 8 is 4. 4 times 4 is 16. Is 16. 16. Negative 13 and 16 is positive 3. Is 3. Is, I'm sorry, is, yeah, positive 3. So therefore, this is a 3. Okay, now 4 times 3 is 12. It's 12. Sorry about all this mess. Negative 9 and 12 is going to be equal to 3 at the end. So what's the remainder? The remainder is 3. Okay, bear with me for a second. Hold on. Now we go over here, do the same thing. This time I hope not to make a mistake. Bring down the 2. 2 times 2 is 4. 3 and 4 and 7. 2 times 7 is positive 14. Negative 14 and 14 is 0. So now the remainder is 0. If the remainder is something, if the remainder is 0, then yes, 2 is a 0 of this polynomial. If it's not 0, then no, 4 is not a 0 of this polynomial. That's how you do it. It has to be, here's the rule, right over here. Let me put it over here. The remainder has to be 0. Has to be 0 for our test number, to be a 0 of the polynomial. And if it's not 0, this is not 0, therefore, no, 4 is not a 0 of this polynomial. That's the basic story of what we're trying to show, that how a remainder theorem can identify zeros of a polynomial. And that's the end of this video. Sorry about the mistake in there.